Over the course of the next two videos, we're going to talk about a fairly powerful technique we're going to use to solve problems throughout the year in this class, which is called dimensional analysis. You're going to need your notebook, you're going to need something to write with, and you are going to need a calculator for this because we're going to do some practice problems. Once you have all those things ready, let's go. Now, in chemistry, the single most common problem that we have to solve is how to convert from one unit into another. Right? So how do I turn something like feet into something like centimeters, because centimeters are generally more useful for a calculation? Or when we do reactions, how do I turn grams of my reactant into grams of my product? I have to convert between those units. Dimensional analysis is how we get there. The way it works is we're going to take a base number and we're going to multiply it by fractions. The key thing is all of those fractions are equal to 1. They just have the same overall value, just expressed in different units. If we were to try an example of this is one that you can do in your head. We have 16 quarters. We want to know how many dollars that is. 16 quarters is $4, right? It's math that we can do intuitively. So let's show you actually how that problem gets set up. So how you do that mental math. In order to do so, what we're going to do is we're going to use something called a conversion factor. Before we can actually make our conversion factors, though, what we need to do is establish an equality. An equality is a statement that says thing A is equal to thing B. In our case, 4 quarters is equal to $1. That's our equality. From that equality, we can make a conversion factor. Conversion factors are just fractions. We put one over the other. For our quarters to dollar conversion, there are two possible fractions that I can write. I can either put quarters in the numerator or dollars in the numerator. Now the question is, which one do I use? Well, the way we determine which one we use is by looking at the unit we're trying to cancel out, because the key thing about dimensional analysis is that units work just like numbers. If you have one in the numerator and one in the denominator, they cancel. If you have two of them in the numerator, they'll multiply. So we want to cancel out all the units that we don't want in our final answer to get to the point where we have the unit we're looking for in our final answer. So that's how we go about setting these up. So let's try to set up our 16 quarter to $4 conversion. What I'm going to do is I'm always going to start off by writing the number that I'm given with its units. So I'm going to write 16 quarters. I'm going to put this over 1. That way I can line up the fractions a little bit better. You don't have to do this, but it's generally good practice. Now I'm going to multiply by a fraction. I have quarters in my numerator. I need that to cancel out, so that means that quarters have to be in the denominator of my conversion factor. If quarters are in the denominator, that means dollars are going to be in the numerator. I can set this up as $1 over 4 quarters. Quarters cancels out. The only unit that's left is dollar, and that's what I want my final answer to be in. So all I have to do is just plug everything into the calculator and I'm done. 16 divided by 4 is 4. The unit left over is dollar. My answer is $4. That's how this works. Now, sometimes you're going to be able to do your conversion in a single step, just like we did with quarters and dollars. Other times, you're not going to be able to do it in a single step, either because there's no direct conversion between those units, or even if there is, you may not know what it is off the top of your head, right? How many people actually know, for example, how many inches there are in a mile? All we do is if we can't go from where we're starting to where we're ending in one step, we do it in multiple steps. So we set up 2, 3, 4 fractions. As long as we multiply them in series and we make sure the units cancel, it will work out fine. So let's try this one right here. How many millimeters are there in 1 foot? Well, I don't know the exact conversion between millimeters and feet, but what do I know? I know that there are 12 inches in a foot, I know that 1 inch is 2.54 centimeters. And I also know that 1 centimeter equals 10 millimeters. So between these three things, I can work my way there. So I'm going to make my little map. I'm going to go from foot to centimeter, from centimeter to millimeter. So 1 foot times 12 inches over 1 foot, because I need feet to cancel out. That will get me into inches. Times 2.54 centimeters over 1 inch, because I need to cancel inches. Times 10 millimeters over 1 centimeter, because I need to cancel centimeters. We plug all this in, and we wind up with a final answer of 304.8 millimeters. Now, because my answer has because my starting number had 2 significant digits in it, I'm allowed 2 digits in my final answer. So 304 rounded to 2 sig figs is 300 millimeters. That's my final answer to the correct number of significant digits. So what I want you guys to do is I want you to pause the video and try this one here. If you have 3.78 weeks, I want to know how many minutes that will be. Okay, so to set this up, we're starting off with 3.78 weeks. I need weeks to cancel, so it's going to go in the denominator of my first conversion factor. I can convert weeks into days easily enough. There are 7 days in 1 week. My next conversion, I can convert between days and hours. There are 24 hours in 1 day. After that, I can go from hours to minutes. There are 60 minutes in 1 hour. Weeks have canceled out, days have canceled out, hours have canceled out. The only unit left over is minutes. That's what I want my final answer to be in, so I'm going to be done as soon as we plug everything in. So 3.78 times 7 times 24 times 60 gives us 38,102.4 minutes. Now again, we have 3 significant digits in our original starting value, so that means I get to keep 3 significant digits in my answer, which means my final answer is going to be 38,100 without the decimal point minutes. Or if I want to express this in scientific notation, 3.81 times 10 to the 4th minutes. So that's all there is for basic dimensional analysis problems. In the next video, we're going to talk about a couple of other different applications, what to do if your unit is a fraction, and what to do if your unit is squared or cubed.